So I'm Jay James. My company Picayune started in 2013. Well, mercury is a pollutant of concern, and its main source is this type of mining. When you go to see what's happening there in terms of monitoring, you find the amount of monitoring effort isn't in proportion to the impact at the moment. When we try to figure out why, it looks like a major reason is the cost of instruments. A mercury analyzer can cost a little over $10,000 to $30-something thousand. Those instruments themselves are really suited for laboratories. We would like to remove the boundaries for mercury analysis, for mercury measurements to be more like the other gas detection that you see. They don't require, a PhD student and a lab. From the beginning, this project started as very academic work, studying gold nanoparticles in electron microscopes and, one at a time, really. So plasmonic sensing is used in pharmaceutical development and in other biological sensing. And what we did is we applied it to mercury because there's this natural affinity between gold and mercury. And at the moment, what's most relevant to this work is our current development around a miniaturization and reduced cost tool. So there's these very powerful but very inexpensive and mass-produced LED photodiode driver, all built into a small rice-sized chip that's less than $10 per part. That's built on the same sort of photonic chips that you see in pulse monitors, the clip-on pulse monitors, or like an Apple Watch or Fitbit. And so we've now been able to build a whole mercury sensor around that's about a cubic centimeter in volume, and now have a device that's many factors cheaper and smaller than anything available. Ideal for these settings where you might not have wall power, where you might be in a pretty remote spot. You want something portable that you could bring to your site and analyze, a wide range of types of samples. You could do water, sediment, soil. You want representative data when you take a sample, and then you also want data that changes something on the ground. So, for instance, by measuring blood and urine in a mining community, you can then immediately give the information, and that can translate into changes in behavior. And the nice part about the wearable is that you don't have a separate person whose job it is to be the analyzer. So the people who are doing the work thoughtlessly get to be protected by the monitor. Where there are no labs currently, or where there are no analytical abilities, but a lot of mining happening, we'd like to, change that to where we have monitors that are living and staying in those communities. Amalgam mining is sort of necessarily destructive, and if we can remove mercury from industrial use or mining uses, that's our ideal solution.